technical session. This one today is entitled Digging for Documentation, a Tale of Reverse Engineering, and it's going to be presented by Daniel Maslowski. I hope I have pronounced your name correctly. If not, I'm sorry. That will guide us through the challenge of working with RISC-V SoCs, exploring complexities, surprise, and strategies for dealing with missing documentation in firmware and operating system. Daniel, please go ahead.
The short introduction. And yeah, hello and welcome everyone to this session. You might actually know me from before because I've given another session just last year. That was around bootloaders, where I also talked a bit about stuff we do in firmware. And yeah, today I want to emphasize a bit of a different topic because one thing we are always craving is essentially documentation. And yeah, I will dig into the details here, pun intended. So yeah, let's just briefly introduce myself again a bit. So, I have backgrounds in different fields. So my field of study was actually IT security and computer science. And in practice, I'm nowadays a software engineer. I mostly do like stuff on web, like application development, also a bit of infrastructure in the past. I've done all the sorts of things you could imagine, including e-commerce, graphical applications and all that. But yeah, in my spare time, I also do stuff with hardware and firmware, all in the open source field, right? So that is the only way I can actually access that, being not, actually in the industry, as some people call it. So yeah, and there is lots to do. Like there is operating systems, there is giant software distributions. In fact, you might know BSD, the Berkeley software distribution, which just like RISC-V actually comes from Berkeley, right? And well, because it's actually a bit of a complex field, sometimes there is some need for reverse engineering. And today I'm going to tell you where and why I am encountering that and what I'm doing. And yeah, I've actually been a RISC-V member for quite a while now. I'm an individual member. And yeah, since a few weeks ago, you can actually also find me on the RISC-V website. But yeah, that's that. So yeah, the agenda for today is, well, very, very roughly, I will give an introduction, and then I will talk a bit about requirements that we may phrase for documentation. And in the end, I will come to a call to action. So this will be a manifold thing. I will be talking, about very, very different perspective on that whole topic of documentation here. So let's start right away and see what documentation would actually mean, because it's a word that you can apply in many, many different fields. So documentation essentially is needed everywhere. You might even know that, like, from your own house. If you live together in a flat share with some other people, then you might actually have a plan for, I don't know, who is cleaning the bathroom this week, and stuff like that. So you're sort of also documenting that. So you're keeping track on keeping things fair. Everybody had their share and so on. And well, in a similar fashion, we also want to keep track of everything that is happening around hardware. So yeah, today we're going to look at these different issues here. So there is somebody who made a bit of a classification of different kinds of documentation. And that was Daniele Presida, just a few years back. Well, actually quite some. It's from 2017. It's been a presentation on the different kinds of documentation, and that was all around software. But of course, we can extrapolate from that a bit. And you can also look at other fields like we're going to do today. So yeah, just very briefly, let's look at those points. You might actually have seen all of those things in the wild somewhere. There's the style of tutorial. So you might also have found something, that sort of navigates you through the process of creating something that you don't actually have a full understanding of in the first place. So it's really, just like a tutor in real life. It's walking you through step by step. And in the end, you will have something working in your hands, hopefully, right? Then there is the how-to guide. So, when you have a very, very specific goal, let's say you've already been working with some kind of hardware or software or something, and you just need a concrete guide for a very specific thing you want to do. Let's say you want to attach a screen to your hardware. It's not via HDMI, but it's maybe over MIPI DSI. So that might be a bit more involved. You might need to figure something out, like, how do you actually do that? So people learn about things like writing device trees, for example. We actually had that in a community chat just recently, where somebody is now trying to, uh, you know, attach a screen to one of their RISC-V development boards. And well, I'm not sure what the current status is, but I can tell you it's not too trivial to do. Then there is the discussions around documentation. So like, if you want to have a specific understanding, you might actually need to dive into details sometimes. So documentation is also not always just set in stone, right? So you might actually need to have a platform for that. Well, and finally, you would need reference material. So what we find in processors, for example, is usually processor manuals. So those manuals would fully describe a processor, with all its bits and pieces. Again, a bit of a pun intended here, but you get the idea, right? So you might have already seen all of that before. And in a similar fashion, we will look at certain examples a bit later. You also find that from the ISA specifications themselves already. So at RISC-V, we actually have a bunch of documents, because essentially RISC-V is a giant collection of documents in the end. So yeah, today we will look at instruction set architectures, we will look at their implementations, and we will look at their applications as well. But let's first talk about something, that might not be too intuitive in the first place. So the question is, to whom does this actually matter? And there are many, many different sorts of people involved in RISC-V now. And that is because RISC-V sort of opens the door for a bunch more things than, you might actually have seen elsewhere. So let me actually start now with the individuals which are involved in or with RISC-V, or you just, bought some hardware and wanted to try it out. And there are many different spaces where you can actually meet people. We have the official RISC-V International Slack team, so you can join it and, start chatting with people. But it's not the only place. There are groups in Telegram, there are some in Matrix. So the Milk 5 vendor, for example, they have actually established a few channels where people are actively exchanging all the time. They're looking at their hardware and, thinking what they can do with it and all that stuff. Then we have a good subreddit. So on Reddit, you have these /r/something. Those are the subreddits. There is one on RISC-V where people are, discussing sort of everything around the existing hardware that you can buy, but also the specifications, how you would implement that. There are, for example, people who actually implement virtual machines that, can emulate RISC-V platforms for you. Now, there is also forums. For example, Star5, they have opened up a forum where, people can discuss their hardware. So Star5 is one of the vendors making SoCs, systems on a chip. And, people buy different hardware with their chips on that. So they would actually need to discuss a bit, sometimes ask questions. And Star5 themselves are also pushing out updates there. And then, of course, if you look at operating systems, we have the distributions, like OpenSUSE, Red Hat, Fedora, all of that stuff. You name it, uh, Ubuntu, of course. And all of those people also, they have their own communities, they have their own, chat rooms, they have their own wikis and all that stuff for exchange. Then on the other hand, we also look at organizations. So I've actually been to a RISC-V meetup in Munich just last year. And the first thing people ask me, well, after a brief intro, like, "Hey, I'm Daniel," they ask like, "Oh, are you part of academia or part of the industry?" And I said, I'm neither. I'm actually like the other side here. I'm just an individual member, and I'm doing things in the fields of hardware and, well, currently mostly firmware actually. And so that introduced me to a much larger group than I would actually have anticipated. There is lots of people from academia, that is both students and researchers, the professors, and you name it. After all, RISC-V is coming from university research, right? Then there is the different chip designers and vendors. There is OEMs like Framework, for example, who just announced another laptop coming out. Well, from them now, also based on RISC-V. There is different industry groups like RISE, for example, the RISC-V software ecosystem, right? And also some others. And of course, the operating systems distributions also have vendors behind them, actually, right? So behind OpenSUSE, we actually have SUSE, like a larger established company. They offer commercial support for, their customers in the end. So yeah, they also, of course, all of them need some sort of documentation and need to write sort of documentation. Now the question is, who should actually do what and all that? And that is what we're going to dive into. So let's look at the current status quo. And if you look at RISC-V International, that's what I'm going to start with because it's somewhat straightforward and easy. Well, we actually have lots of repositories on GitHub. That's where we are developing and keeping the specifications. And how it works is, on the one hand side, we have a template. So when you set up a new repository to, write your own specification, or, I don't know how it exactly works, right? So you would need to establish a group or something. Then you would use that template. And on the other side, there is also a guide for doing development, so you actually already have documentation for writing the documentation. How cool is that? And now when you're doing that, you would, over time, you would be writing your documents, and at some point you would want to make releases. So in the end, people might actually want to download PDF files from GitHub. So that is what is being done also, right? So people don't need to clone the repository and, need to read through the source files, but they can actually get a final working PDF. You would usually find that in the release attachments. So if you look at GitHub, like I've just put two examples here, the ISA manual itself, there are releases, and on the release pages, you would for each one find a PDF file, and I think even EPUB files, right? So if you want to put that on, I don't know, one of those reading devices, that also works. I also put the SBI specification here as another example. We just recently had the release version 2.0, and of course, we also have a PDF attachment. So you can just download all of that to your local, files, and then just browse it from your document reader. So yeah, it makes it very, very easy and convenient for you to have a library. And of course, because it's on GitHub, it's actually very easy for people to contribute. You can just raise your own questions. Like on GitHub, there is the issues feature, right? And if you want to contribute something, because you maybe had a hard time understanding something, or something wasn't too clear, you might want to clarify something. You can just join the development by filing a pull request already, right? Very, very straightforward. Now, let's take it to the next step. Let's look at what happens when a vendor of SoCs or RISC-V cores is actually working with a specification, right? So they would take that specification and they would be implementing it. Now, when implementing it, there are different nuances of maybe having an open source variant of that, or maybe not, or maybe partially open source, right? So sometimes there are like reference open source implementations. An example would be the T-Head cores, for example. T-Head is a vendor who is making RISC-V cores, and you can find the open version of those cores on GitHub. For example, C906 Open is the basis of what you find in the Allwinner D1 SoC. And then, you would have a bit more in that core, and then also everything else like peripherals around it in the actual SoC in the end. So yeah, those cores, as they are used in the SoC design, they actually come together with stuff that is coming from third parties. And that is where it's now getting a bit hard with documentation, because the third party is now actually the right holder, right? So it's up to the third party that they would buy from, or you as a vendor would be buying from. It's up to that third party to decide how much you can do with that. So you might need to choose your third parties very, very carefully when it comes to buying things that you can actually document yourself again, right? So your customers or end users who might be demanding documentation, they would be very lost if you would need to tell them, sorry, we bought something we cannot actually disclose, right? So that is where people get very, very upset. So yeah, it really, really depends on the vendor. And I've seen things ranging from, 0 to 100, if you will. There is some where there is currently no publicly available documentation at all. There is some where, you would find something, but it's watermarked or it's sort of restrictive. It might not even actually contain everything. Sometimes there is, some hardware that is already being sold, but there is actually no manual yet, and it's published with a delay. Sometimes it is just a draft and so on. So yeah, you might want to carefully choose, depending on who you are, what actually you want to buy, right? So I personally prefer buying something where I already have the documentation, so I can actually know what I am buying, right? So you don't want to buy something blindly, but you want to buy something that you can actually know and understand. Now, it ranges in different shapes and forms. There are some vendors publishing something in HTML, right? So they would put up a website. It might actually also be something fancy. Sometimes, you might get the PDF of that. Like Starfire, for example, they have something that you can just browse on their website, a very, very nice version of that. And then there is also the option to download a PDF. And you can just keep it locally, so you don't need to load the website all the time, which is very, very convenient, especially if you're traveling, right? So accessing the internet when you're traveling, depending on where you are, can be a bit difficult. So it's always good to have a PDF version. Just recently, just as an anecdote, I actually encountered something I found very interesting. The vendor Space Me Tea, I'm not sure how to pronounce that, to be honest. They're the ones that are making the SoC that is baked into the Banana Pi. It's called like F3 or something, I think. It's fairly recent. The SoC is called K1, or the BGA variant of that would be M1. And they put up a website with some documentation that is actually, a fancy application that you would be clicking through. But that application, of course, needs a data source. So I figured there was actually JSON files being, stored somewhere, and they would be loaded at runtime. So since I'm coming from the field of, web development, I knew how to deal with that. So I downloaded those JSON files, which frankly just contained Markdown, and I created a PDF document from that again. So, I had something again which I could easily take with me and also read while, I'm traveling. I travel a lot by train, for example, right? So that was much more convenient for me. And well, of course, depending on the vendor, it can actually be very hard to give contributions back, right? So it might be that you find something in a manual where there is an error, right? So you would like to share with your other friends or, with the wider community, like the whole RISC-V community, or, everyone who bought something from that vendor. You would like to share your findings and say, hey, we actually need to correct something here. Now, how do you do that though if, you don't actually have access to the source? And we will get a bit further into that a bit later. Yeah, I just wanted to point that out here now, because this is already like a, quite of a different level of what we're talking about compared to what we have in RISC-V, like with the RISC-V international repositories. And now let's take another step. And the last thing I want to look at is how it is with OEMs and end products, right? So if you want to buy some hardware, you would also like to know how it works, right? So usually when you buy a laptop nowadays, you would just open it up and it would just work, right? But it's a bit different if you buy a single board computer, for example. So it's not like you just open it up and it just boots up or something, right? So you might actually need to do something in order to get it to work and so on. And so we need a lot of documentation for that. So this is where it's just getting more and more, right? So the more we're getting toward an end product, the more documentation we actually need. And so what it's currently like is we now have a bunch of SBCs that have been released, like single board computers, right? like the Nerja, for example, from Allwinner. We have the Vision 5.2 from Star 5. There is some from, the Beagle 5 series, and so on. A good bunch of hardware. Now we're also getting the first laptops. There has already been a tablet and stuff like that. So if we look at the current timeline, it's actually quite amazing, right? So in 2021, that was when the Nerja was released, and I actually bought it myself, and that's how I got involved with RISC-V after all. And now, just 3 years later, we already have a good bunch of laptops being announced. Like, I'm aware of at least 4. But what actually happened was there was a bunch of end customers, who have received something that was, sold as open source, but it was actually unfinished. So, it was very, very hard to deal with that. And I put open source in quotes here because it wasn't actually open source. It was only partially. So, but partially open source doesn't mean open source, right? It's like, let's say you're vegan and I offer you a meal and I say, hey, it's vegan. And you figure out, well, there is actually meat in there. So it's not really vegan. I say, yeah, but it's partially vegan, right? Because there is broccoli next to it or something. That's not how it works, right? So we need to be, a bit more strict with that stuff. So yeah, for example, if you sell hardware and you say it's open source, and I'm asking you, okay, great, where's the RTL? Where can I look at the chip design? Well, that is what was frankly missing in this instance here. I don't want to name and blame anyone here, right? I just want to raise the awareness that if you look at this stuff and you're looking for documentation, you might actually run into these issues. So just because something is labeled in a certain way, just look at it for the real deal, right? If you don't find anything, then it's actually not what it says on the package. Now, depending on the vendors, it is also a bit difficult with the software. So we have a bunch of software in the ecosystem. Like for the bootloader, mostly vendors will be using U-boot. Well, not only as a bootloader, but also like for very early initialization. They would usually cram OpenSBI in between, or they might actually choose to go with Orboot, which I haven't yet listed here because no vendor has actually contributed to that yet. Then we have Linux, the kernel, and all of those are actually, being forked. Sometimes you only get binary releases. Sometimes they might actually contribute back to upstream. So people are asking, hey, how can I actually run an upstream kernel? How can I run upstream U-boot on my device that I have here? So that is something that you would need to, frankly, document. We will also come back to that in a bit later. Sometimes there are actually guides available, right? I've actually seen that there were manuals where you could see how to recover your board, for example. It depends always a bit on the specific board, how it works, right? So you need very, very detailed instructions usually. It might be that two boards that are very, very similar actually have very, very different flows of doing a recovery. It really just depends on the specific design. I've seen schematics, which I must say I'm very, very glad about. In RISC-V so far, almost all the boards I have seen actually came with schematics, so that is a very, very big plus. And even board design. So when you design a board, so usually you would use a professional tool like KiCad, for example, right? Like, the Minute Reform laptop is, for example, designed with KiCad. You would also, get all of their design files. And then you know how to work with that. Well, actually, the Minute Reform is a very good example because it's a modular laptop. So I could put a module in there, let's say the Mars compute module from Milk5, for example, which would be sort of pin compatible, I would assume, but I really need a lot of documentation in order to figure it out and get it to work. And with that, let's switch over to talking about requirements that we would have toward the different parties that I just listed, and eventually, of course, ourselves in the end. So we have something to evaluate. So I've, made this seemingly comprehensive list, but it might not actually be complete. So I would just walk from top to bottom, and it's exactly what I just mentioned before, plus some more software at the top. So we're starting with the ISA specifications, and that is what we already have. So I put a smiley face in here because you can browse everything that is happening in RISC-V on GitHub, right? So you find all the specifications, you can download the PDF files as we just said, and that is already all the basics that you would now need to implement a RISC-V instruction set, or maybe write a compiler for it, or bare metal software and stuff like that. Now, for a specific implementation, so for a RISC-V core, if you're making a core, I strongly want you to consider community contributions, right? So we do have many people who got interested in RISC-V because it is open specifications. And if they see that you made a nice RISC-V core, right, they might actually want to contribute to that. So yeah, consider just also putting things up on GitHub. And if you have your implementation specifics, if you look at the specifications, you will actually see that in a bunch of places where it says it depends on the specification, or it depends on the implementation, or it's defined by implementations. Those are the things you definitely need to document, right? Because otherwise, it's always hard for people to figure out, well, how did you actually implement this in the end? I could name a few examples now here. One thing, for example, I encountered was the delegation of exception interrupts. So in RISC-V, right, we have the different processor modes. We have the machine mode, we have the supervisor and the user mode, and coming up at some point hypervisor mode. But let's neglect that for now. Now the thing is, if you are in a machine mode, you can actually delegate exceptions down to the supervisor mode, and there is a register for that. Now it depends on the specific core that you're on, whether or not certain bits of that would actually be set in the end or not. And I just recently figured out with some hardware I was working with that effectively the bits I was setting were actually not being set. But I thought so from the manual, but maybe I misunderstood. And, so yeah, really highlight those things. They can save people weeks, if not months of work. Now, the same thing goes to SoC vendors. So if you write a manual for a processor, like, the peripherals and all of that, now also consider maybe putting that up on GitHub, because just like what we do in RISC-V International, you can also just generate from your sources your eventual PDF, right? Of course, make up your mind around third-party stuff. I don't want to dictate anything here, but yeah, I can just say from my point of view, as somebody who is doing a lot of firmware stuff, it really helps if we have something very accessible. Then in a similar fashion with schematics and board designs, also consider publishing the sources for that. I know that not everybody is using open tools, so some also use proprietary tools, so it might be a bit more difficult. But there is, for example, the Open Source Hardware Alliance, which has a certification program, and the more you actually publish, the more it contributes to being eligible for a certification. So yeah, I strongly recommend you to look at that. I'm not going into detail right here now, but yeah, that is definitely something together. And then you can actually sell something with an actual official label, right? So then you can say, hey, this is actually open source hardware compliant. Now, the next thing that we find in processors is mask ROMs. So mask ROMs are essentially like software, but baked into the chip. And they have their own little protocols. You might be able to assign your firmware that you put on a machine. You might, need certain tools for flashing that and all that stuff. That is also something we definitely need documentation for. Sometimes we use, tools that come from vendors, but they're only in binary form. Then we would need to reverse engineer that again. That can be very painful. So it would be very helpful for us if we actually, get open tools for doing that, or just documentation around that so we can implement our own tools for our specific purposes. And also we're going to look at that a bit later again. Now, regarding firmware, same thing. We definitely need the sources for firmware, right? So in order to work with a development board, I need to be able to have the firmware for it. I need to be able to tailor it for my needs, right? So if an OEM is trying to anticipate all my use cases, that is usually not really possible. So, people always have their different requirements. And well, as much as they want, if they don't have the sources to make their adjustments, it gets very, very painful again. So yeah, of course, you need to consider licenses. When you put up sources, always, put your license in that. We would be very happy usually about GPL license. So that is what you find in U-boot, for example, right? And that is also what we have in ORBoot and also in coreboot, like many open source projects, also Linux. So yeah, that is usually the most compatible one. But also, consider having maybe something compatible for people using other licenses, like a BSD license, for example. It's quite different. You can't just take code that is GPL license and use it in a BSD product. That doesn't work. Now, especially for firmware, you need to provide how-tos, right? So for people to build their own firmware, to flash it, maybe to also make adjustments if they need them. Need to document how the firmware actually behaves, right? So for example, I was just mentioning the registers that we have in RISC-V. You would want to communicate like how you set up your firmware and what the operating system might actually expect. And then also document how you can integrate your operating system, right? So there are different ways of loading operating systems and stuff like that. And, depending on the specific firmware, there might actually be options like, for example, U-boot has a UEFI option that may or may not be enabled, right? So if I have a UEFI binary, I want to load that on a non-UEFI platform, that wouldn't work, right? So I would need to know how to integrate stuff. And eventually, the operating system distributions, they're usually doing a lot of great work, having well-maintained wikis, right? So the Arch wiki, for example, is very famous for actually doing that. And what I've seen in, for example, OpenSUSE and also Red Hat or Fedora, they have a lot of documentation also around certain hardware that they support. And that is usually a bit harder to find for people. So when you're selling hardware, maybe get in touch with the operating systems distributors so that you can push out preferences, so it's easier for people to find things. Now, that being quite a mouthful, I want you, if anything, keep this one thing slide, because that might actually be your way to go reference if you want to document anything in hardware. And now we're switching over again. So we're going a bit into details now. I've already, teasered that a bit. So I've already called for putting things up on GitHub. If you, make SoCs or cores, that would really help us. And there is actually a very simple thing you can do depending on, certain like copyright stuff and so on. But, if you write your own VHDL, you can also put that on GitHub and you can establish something that would generate documents from VHDL. You might add your annotations or whatever around that, right? But it's definitely something that is possible, and it might actually reduce your error rate, right? So if you look at certain, issues that sometimes come up in manuals, let's say a register, I don't know, somebody mixed up some bits or something. If you had generated that from an actual source for the design of the hardware, then you wouldn't actually run into that issue. You might just retain the issue that you already had in the design, but yeah, you would have that anyway. So what I'm saying is you would have more consistency. Consider letting the community ask questions, right? Let them file pull requests, let them file issues for clarification if they have any questions. Yeah, as I just said, you can just use release artifacts. Same thing that we also do in RISC-V internationals. They can give you PDFs and so on. And as a vendor, you would usually have a website, so you can actually put a link to that PDF on your website. So it's the same thing as if you were hosting that PDF somewhere else in your, I don't know, whatever storage. So yeah, you would get that as a service then. Definitely include the full memory map, right? So when I'm working with an SoC, I want to know where things are in memory, right? So that definitely makes things easier for me, especially if I'm working on operating systems. Trying to translate from like other operating systems or boot components is very hard. Might actually introduce license issues again. So we definitely need to have that in manuals. The same goes for, certain identification registers or eFuses or whatever have you. And frankly, yeah, all the peripherals, and yes, including DRAM. And I'm going a bit into detail with that because that is something I often encounter to be not so open. We had a brief discussion on that with Star5. If you remember my previous talk, I was actually in touch with them and asked if I could, get documentation for the DRAM controller they were using. I was offered an NDA, and I said, well, that's not how it works, because I need to be able to publish that. So I cannot sign a non-disclosure agreement. I would need to be able to disclose. Yeah, somebody's writing, this is all very relevant and on target. As a very hardware-centric open source organization, we really appreciate the recognition of what's required in order to navigate through the workflows. It's not that simple. Yeah, thank you very much. Definitely. Coming back to that example here, well, frankly, for Star5, we actually do have open source DRAM code. I was able to take that, just last year for the Vision 5.2 board, or the JH7110 SoC that you may know from it. I took that source code and I translated that, for our own firmware or boot, which is written in Rust, right? So I took the C code and translated that to Rust, and that was actually very straightforward to do then. There were a few things which, I had to struggle a bit with, but in the end, it was mostly straightforward. Now, I've also now seen DRAM blobs coming up. So blob as in binary large object. That means we only have some parts in binary form. In this instance here, that was space me t. Still not sure how to pronounce it. So yeah, they have a DRAM blob that is baked into a header file. So if you look at that header file, I put the specific link down here. You will actually see there's like tons of bytes in a very large array. I mean, I could dump that, I could load that into Ghidra, right? But it's really painful to do that. So if possible, please, open that source code, add documentation around that, or maybe disclose, hey, we cannot open source this part because we bought it from a third party or something. Well, frankly, consider buying from other suppliers, because I've seen many vendors actually buying from suppliers where they could publish the source code. So it is definitely possible, right? There are even open source implementations of DRAM controllers. I've seen them. Now let's see a bit how SoCs actually boot, because, as a consumer or, firmware engineer or operating systems developer, this is now how it starts with me, right? So I want to boot up my machine. So, and this is actually a slide I already had last year, but for the sake of the next stuff coming, I want to recap that. So a typical system on a chip would have some code baked into a so-called mask ROM. That is really baked into the chip itself. It's also sometimes called something else like boot ROM, or there is the term ZSBL that we also have sometimes in RISC-V, meaning zero-stage bootloader, right? So it's like stage zero, the thing that is coming before everything else in a sense. So yeah, and that is the stuff that you cannot actually change. So you need to know how it works in order to continue from it. Now, those boot ROMs, they often offer certain load-up protocols. So, usually there would be code that would be looking either at like different peripherals, like let's say an SD card interface or a SPI flash interface, and we would try loading code from that. Or, there might be like GPIO pins that you can set, or sometimes it's a fallback mode, where it switches over to something like USB or maybe UART, right? Or some sort of serial protocol, which you can actually use for development. For example, Allwinner, they have a protocol called FEL. The JH7110 and 7100, they have a protocol that is called Xmodem built into it. So I can just load my code over that. And also other vendors I've seen now have something similar. So yeah, depending on the design of the platform now, it depends on how you can design your different boot stages after that, right? So yeah, it's really use case specific. So if you look at the code in U-boot, for example, it's always a bit like there's some platform specific parts, and then at some point there is a U-boot generic part where, you have like the part you can actually interact with, and that would load your final operating system and so on. And in a similar fashion, it also works like that in Orboot, right? So we have platform-specific early implementations, and then we have something that is becoming more and more generic to load your system. And yeah, we developers definitely need documentation for that. There is now the LiGiPi 4a. The manual for that has been published rather slowly. The SoC on that is the TH1520. People were then asking like, okay, how does the boot ROM or mask ROM actually load an image from like eMMC? How does it load that to RAM or whatever? So somebody here was trying to actually push U-boot upstream themselves, right? So do not underestimate the community. There are many, many people actually willing to do a lot of work. So yeah, again, if you are a vendor, definitely consider working with a community. And of course, track the progress that is happening. And that is actually something I'm also very happy to see. There is a community around Allwinner that you find on Linux Sync.org. They're documenting their own status for putting stuff in mainline Linux, but also U-boot. I'm not sure if that is a different page. You would have to check again. But definitely they are tracking like their current status because they are taking care of pushing things upstream themselves. There is the JH7110 now, where Star5 are actually tracking upstream progress themselves, and there is actually a lot of progress happening. So over the different kernel releases, you see more and more and more code trickling in, and so far I can actually boot an upstream kernel, and it would just work. We actually just recently brought that up with NixOS, for example. I sat together with one of the NixOS users at a conference, and we managed to boot up a final upstream kernel, right? So that is always what you want to have in the end. In a similar fashion, there is a sheet for the TH1520 SoC that is now also getting more and more toward the upstream projects. I put the link here for reference. As you can see, it's a bit long, but yeah. I will have the slides uploaded later on, so you can actually click through all those links here. So yeah, no need to copy that now by hand. Now there is operating systems, of course. I already mentioned BSD earlier, so they have a different license, and they could actually use some help. Mitchell Horn just gave a talk at the BSDCan Developer Summit, summarizing their current state of development on RISC-V for FreeBSD. I put the link here as well if you want to watch that. There is a bit more in that, but yeah, it actually starts with the RISC-V stuff, and he's walking through like what hardware is currently supported, what the current state of development is, and where help is actually needed. So you will definitely find something to contribute here, and especially if you are a chip vendor and you want to support OpenBSD or FreeBSD or any of the BSDs, maybe consider that. They might actually be one of your customers. All right, and with that, now let's come to the last part, which is a call to action again. But this here is now the call to action to the community. And that brings us to that topic of reverse engineering in the end, where, I actually have done quite some bits, but also other people. And I want to show you a bit what we've done so far. So first, let me tell you what we can actually do. So I think at RISC-V International, we could guide people a bit more towards upstream, and that is both for operating systems but also firmware. We already have the RISC-V Exchange platform where you can browse like sort of everything around it. But yeah, maybe we want to set up something like, I don't know, tutorials.riscv.org or examples.riscv.org, and then ask people to contribute their guidelines, right? Curation might, of course, be necessary there, but it's definitely doable, and we could set up repositories for doing that, just like we're doing for the specifications. And on the other hand, end users or other contributors, when you receive any hardware, see how it works. Of course, I mean, you want to use it eventually, right? So that's why you bought it in the first place. And if you figure things out, share that stuff with your community. Whatever you find. You might want to dump some mask ROMs from the SoCs because usually they're not available elsewhere. We've actually done that with a bunch of people. Start reversing the binaries. It's also a very nice way of getting into things like Ghidra, for example. And yeah. Oh, yeah, Michael is saying has to leave for another talk. or another meeting. Yeah, you're welcome so far. So let's continue. Dumping mask ROMs is definitely something that helps us, especially if the mask ROM is not documented, right? So we can get a bit more of an understanding. For example, I've looked at the mask ROMs of the JH7110 and some of the SoftGo SoCs, and also like the Allwinner D1, but just a short bit. And I can definitely tell you it gives you a lot more understanding of how that hardware actually works. And it also helped me a bit with the Orbit project for the JH7110. So that is what it looks like. In this instance here, it's just a screenshot from the DRAM blob that we have for the SpaceMe T K1 SoC. So, I told you there is this bunch of bytes in a header file. I just copied that out and, wrote that as a binary file again. I knew the base address of where that would be loaded, right? So I could just load that into Ghidra. The question here is now, how do you actually dump the mask ROM? That's an excellent question. So, a very simple technique is, if you already have, let's say, U-boot running on an SoC, then you can enter the U-boot menu, right? And then you can start, typing things. If you know the base address of a mask ROM, then you can read that mask ROM from that base address in memory. You just need to provide the size, and you can copy that to somewhere else in memory, or you can also just push that out over TFTP, for example, or write it to a USB drive or an SD card or something like that. So that is one way to go. What I have done for the SoftGo SoCs was I have just written some small code that would just start reading from the memory address where the mask ROM starts. I was printing out the bytes just ASCII encoded, like each byte would be 2 digits in hex code, right? So I just printed that out, put that in a file again, and transformed it back to its binary form. And I actually put a tool for that on GitHub. You will find that in the platform system interface organization on GitHub. There is a few other techniques you could use. Technically, you could also do that from Linux. It depends a bit on the memory projections being set up. But yeah, in general, you will be able to dump a mask ROM. That might actually be a very good opportunity of tutorials that we can, put up on the RISC-V website, for example. So yeah, and with that, let's head over to vendor specifics. So I already told you that each and every SoC has its little mask ROM, and there are certain protocols in it and all that. So we need to have tools to work with that. With the Star5 SoCs, we've actually already done quite a bunch of stuff with that, just because it was so nicely available. And we actually had a lot of documentation already. So, we kept working with it more and more. There is a recovery binary to which we currently don't actually have the source code. We might actually be able to construct something very similar with Orbit now, because we are very, very far in the project. I put the references to all the respective GitHub issues here. I've seen this issue where somebody is asking the X modem protocol that is implemented there. They were actually having some issues. I think it's actually with the UART setup, because there were some there are some USB serial converters with which it works well, the FTDI one, for example, that worked very well. But there were others where you would get errors quite frequently. So yeah, that would be very hard to work with. So just documenting that would be very helpful. There is actually a recovery manual, and that could mention that. In a similar way, OTP fuses, so OTP is one-time programmable fuses. The design of the secure boot flow, right? Like how it actually starts in the hardware, what it reads, what headers it reads, and binaries it parses, and so on. I started reverse engineering that to quite a degree. Most of that is now in my VF2 header repository that I also put in here. And for loading a binary, and that would be for the X modem protocol again, we also made our own loader, because it wasn't exactly X modem, so there were like some quirks. Sometimes you would get timeouts or something. Anyway, so yeah, VF2 loader is then the tool I made for it. In a similar fashion for the vendor Buffalo, well, we also have a loader. That one is written in Python. I at some point also forked it. Here's my link to GitHub. Samuel Holland, or Smeal, as you might know him, also has something on GitHub from where I forked eventually. Yeah, you will also find things in there. I haven't done much with that hardware, so yeah, I'm not going into details right now. Yeah, with the SoftGo SoCs, I told you I also worked with them a bit. They also have a protocol that is based on a serial port, and I made a tool for it called sg_boot, because yeah, there is something in their uboot repository, if I remember correctly, or FSBL repository, something. But yeah, I needed something else, and yeah, so yeah, I wrote my own tool for it and extracted the understanding of how that loader works from their code. So yeah, it's always good to have this sort of reference code, and it might even be easier to just have straight up documentation. And I could actually understand a bit more of that from looking at the Mascrum again in Ghidra. And yeah, if you look at the star5 repository, we actually had a binary initially from which we derived the tool to create the header. Because in the beginning, there was only a tool in binary form. And so what I did was, and you'll find that actually in the issues I've raised, and which are now closed, I have created a few files and then just ran the tools over it and looked at what the output would yield. So I was seeing certain things like, hey, this here looks like, okay, this is like the size of the header. It's always constant. So, right, there is like a well-defined form for it, probably. Then I looked at, some data in it. There wasn't actually much. It was mostly just zeros. But there were a few fields where I could say, hey, this here is like, you could supply a version number, and that would be embedded in a certain position. And that would be something that looked to me like, well, it's sort of random bytes, but it's exactly like 8 bytes or something, right? So no, 4, right? So 32 bits, and that looks to me like a CRC32 checksum. And of course, eventually it turned out to be a CRC32 checksum. Now there's different implementations of that, but yeah, somebody figured out the correct configuration that you would need for CRC32. And now we have this vendor SpaceMe T. I don't know. There is also a tool for them in their repository. So yeah, there is more work to be done. I think that is also written in Python, if I remember correctly. And that also just creates something on top of files. Yeah, I will look at that as well. I've already done the first few runs, and so far it looks like yeah, it's somewhat straightforward actually. Yeah, with that, so far, thank you very, very much. For reference, here's where you find me on the social medias, like Twitter, or formerly Twitter X, and so on. My GitHub, my Twitch channel, where I sometimes do live development. Well, I haven't done that in a while, but my YouTube channel, where you find videos archived. Related talks I've given in the past. So last year I talked about bootloaders here at RISC-V International, and I gave another talk recently at the Open Source Firmware Foundation, where I talked about when you do hardware design, you can actually, generate all the code up to the operating system just, from your hardware design sources, technically. Yeah, check that out if you want. And today's presentation, Digging for Documentation, here is the link to my website, where you can also download the PDF again. And of course, it's all CC BY 4 licensed.
Yeah, you can also talk with Daniel in if you join the RISC-V Developer Boards meeting. So Daniel is an active member of that group, and he also provides a lot of insight about new boards and what you can do with them, and especially what is not working. So
yeah, absolutely. And you can also meet me in person actually next week. If anyone is at the RISC-V Summit Europe in Munich, I will be there the entire week.
That's great. So, folks, do you have any question for Daniel right now? Yeah. Thanks, John,
Oh,
for the
cool. Yeah,
presentation.
somebody is saying thank you. John Sanders is saying thank you. Very relevant for my team as a hardware IP documentation developer. Yeah, you're welcome. And yeah, thank you for actually listening here.